decay at time constant about 200 milliseconds. Sometimes there is series of decays with short-living isotopes. Ion chamber. It is at high voltage. Inside is a cotton filter filled with dust and central electrode. And here is high voltage capacitor charged at 300 volts. We disconnect it before opening the box. Circuit is based on electrometer operational amplifier. Feedback resistor is 3 gigaohm because I did not have 200 gigaohm, and the trick is to use voltage divider on the output, which makes efficiently this feedback resistor larger by a factor of 100. 100 ohms protect against self-oscillation. Faraday cap is at high voltage, 300 volts, so it is dangerous to touch, and should be careful not to touch the middle wire to the Faraday cap wall. That will electrocute the amplifier. Output pulses is about 200 milliseconds long and 20 millivolts in amplitude. In the box we see a 3 gigaohm resistor, operational amplifier, 2 batteries supplying plus and minus voltage, and basically that's it. And here in the hole goes a central electrode. Capacitor is charged to 300 volts by connecting to 220 volt mains. And after charging, it is carefully connected to the Faraday cap. In the Faraday cap we see cotton sample with black soot from filtered air, and it contains some radon decay products. So we close the cap, switch on amplifier, and on scope see pulses. Sometimes decay happens to short-lived isotopes, and there is a small shower of radioactive counts. If it is just room air, the counts are very seldom, so I use pre-concentrated radioactivity on cotton sample using vacuum cleaner.